So what is an inverse trig function? When I do this, I'm looking for a what? An angle. An inverse trig is finding the angle whose sine is 1 over the square root of 2. And the only ones we know how to do are 30, 60, 90s. So I'll draw a little triangle here. If this is 30, 60, if this is 2, this is half the hypotenuse, and this leg is the square root of 3. The other one is the 45, 45, 90s. So this is 1, this is 1, this is the square root of 2. So when you see the square root of 2 there, you're going to think, oh, it's probably 45. Okay, it's not rationalized. It could have been rationalized, but I see square root of 2. If I rationalize it, it's the square root of 2 over the square root of 2. Remember how to rationalize? And so it's the square root of 2 divided by 2. Well, what's that angle? 45. These are equal. I should have marked this. Or pi over 4. You'll be in radians, so this is pi over 4. The only problem I have is if I get negatives. If I have positives, it's not hard. So what I do is I rewrite this. This is theta. And I say the cosine of theta is equal to the square root of 3 over 2. Whatever works for you. You could memorize the reverse of the triangles if you want. I think it's easier just to think of this as the cosine of what angle is the square root of 3 over 2. So what angle? 30. So theta is pi over what? 6. The only ones we have to worry about are the negatives. And the negatives aren't hard if you're doing sine and tangent. Inverse sine and inverse tangent. They're just going to be the negative angle. The cosine is the one that's tricky because you have this restricted domains. Okay, so what about this one? This means the tangent of what angle is equal to the square root of 3, and it's really over 1. So you look back up at my triangle. Which angle is that one? 60. Does that make it easy if I just have those triangles there? So when you go into the exam, just draw those triangles down right away in your blue book or whatever it is, and it's legal. And then you just look at it. Now, if this is negative square root of 3, all that's going to happen to my angle is it's going to be a negative pi over 3. That's it. We have to restrict these inverse trig functions so I don't get more than one answer, because there is more than one answer. The inverse of the tangent function, there's an infinite number of inverses. So here's the tangent. I just want to restrict it to be this way, but look at this. If I take all those, if I can draw it. Here's the one that's at the origin, and then here's the next one. Is this a function, these green ones? No, that's the problem. So what we're going to do is just restrict our input so that we're between negative 90 and positive 90, that's all. And what about the inverse cosine of the cosine? What do you think those are going to do? It cancels out, so what do I get? Well, that's a 0.6. You can't always do that, so you have to check. As long as these are positive, we're okay. As long as we're talking about positive numbers. Well, let's see what this means. I mean, you can try it on your calculator. Pardon? Right. If that's a negative, then I got to be more careful. Yeah. Should be. Anybody try it at the calculator? Who's got a calculator out? Make sure I'm not lying to you. You have to be careful, though. With my S and angle, that's certainly between 0 and pi, which is 3.14. But it doesn't always work, so you do have to be careful what you do. Now, when they first started putting calculators in, they were really quite nasty. It's correct. They were quite mean and put in other kinds of numbers there that you had to go over to the second quadrant and fool around with it. And it really took me 15 minutes to do one multiple choice problem. So to change degrees to radians, well, here's your ratio. It's 180 degrees over pi, or it's pi over 180 degrees. So if I have 30 degrees, I'm going to multiply by one of these where the degrees will cancel. So So I want to do the second one. It's pi over 180. I never remember which ratio it is. But the degrees will cancel. So you get 30 over 180, which is 1/6. 4 pi over 6. Boy, I remembered is I want a 30-degree angle to be pi over 3 because of the 3's, but I know that's wrong. Pardon? What? No, she asked the question. The question was, how do you change degrees to radians? So if I have pi over 3 radians, I would multiply that by 180 degrees over pi. So that's 60 degrees. If I have 2 radians, I'm going to do 180 degrees over pi. And it's whatever it is. Pi is just a number. It just bothers you when you don't have, the pi's don't cancel. Okay, here's something we also need to understand, the relationship between inverse cosine and inverse secant. It's not a reciprocal. I would think it is, but it isn't. I know that the secant of theta is 1 over the cosine of theta. I'm tempted to say that the inverse secant, well, I can't say theta, of x. Oh, what's on the second page? Oh, yeah, we're going to skip those for right now. So it wasn't fixed when we printed it off. We'll need that Monday. So inverse secant of x is not equal to 1 over the inverse cosine of x. It feels like it should be, but it isn't. So here's what we're going to do. We're going to take inverse cosine of x and rewrite that as an angle. That's an angle, right? So that means that the cosine of theta is equal to x over 1. Right? And then I have inverse, secant of x is equal to theta. That means the secant of theta is equal to x over 1. And actually, I'm not going to use that one, but let's look at this. But that's what that means. So if I draw my picture, here's my theta, and the cosine is x over 1, then that means this is x and this is 1, right? That's right, the square root of 1 minus x squared, which is what I'm going to end up using in a second. But I don't need it right now, but that's right. What is then, looking at this triangle, what is the secant of my theta? I'm actually going to like to get rid of this because it doesn't help me at all. So what's the secant of theta of this triangle? It's what? 1 over, cosine is adjacent over hypotenuse. Secant is 1 over x. Now let's take these two equations and solve for theta. What's theta equal to? Inverse secant of 1 over x. What's this theta equal to? Inverse cosine of x. How are these related? The angles are the same, right? Theta is equal to, yeah, where's the reciprocal? It's not in the secant and the cosine, it's in the fraction. Kind of weird, isn't it? If I want to write out this one, if I have inverse secant of x, then that's inverse cosine of 1 over x. Yeah, it's not what I would have expected either. I just flip this one and that'll flip. I could go through the whole same process again and get the same thing. Get it? Doesn't matter. If this is x and this is 1 over x. This is 1 over x and that's x. These are reciprocals. These are reciprocals. Doesn't matter. Whatever this number is, that's the reciprocal of it. So if this is 2, then that's 1/2. So what I do is I don't even bother remembering that because that's too much to remember, right? So instead, I'm going to take this and just rewrite it this way. Inverse secant, I mean, I could do it, the cosine was 1/2, but I don't want to do that. That means the secant of theta is equal to 2. Right? And then I'm going to draw my triangle. If the secant's 2, what goes on this side? 2, and then this is 1. So this is what side? Because I can do it. Square root of 3, and here's my theta. What's my angle? This is 60, right? Is it right? So this is pi over 3. So this is equal to pi over 3. So I'm looking for an angle. Even I have to remind myself I'm looking for an angle. And that's all it is. So I don't bother with all that. You could say, because I have this, it's inverse cosine of 1/2, which means the cosine of my angle is equal to 1/2. And there it is, 1/2. I think it's easier just to do this. And if I don't like that, I'll actually come in here and say, well, secant of theta is 1 over the cosine of theta is equal to 2. So cosine of theta is equal to 1/2. I mean, I can work it out. I don't have to memorize that. But I don't have it memorized. I might by now. Sasha? They'll have the same as the original function, so secant will be the same as cosine. And cosecant will have the same domain as tangent will have the same domain as the sine. Well, sine tangent and cotangent, excuse me. Cotangent will have the same domain as tangent. Cosecant will have the same domain as sine. Okay, we have to do a little footwork before we do this next thing. We're going to do these identities. I never memorized them. I just worked them out. Some of you said in your homework, those of you who did your homework, ended up with a secant squared of y. I forgot what y was. But how did you do that? And I said, you just leave it, because I haven't taught that yet. Now I'm going to actually teach it. This secant squared of y will come from one of these identities. And I don't even bother memorizing them, but I work through them. So this is the sine of some angle, because that's what this is. And it's saying that the cosine of my angle is x over 1. Right? So I'm going to put my triangles here. And the cosine is x over 1. So what goes here? Cosine of this angle, that's x, and then this is 1. And then how do you find this side? You see why it's the square root of 1 minus x squared? Because if I square this and I square that and I subtract, Pythagorean's there. That's right. So it's 1 minus x squared. So now I want to find the sine of my angle. And what's the sine then of my angle? So the sine of my angle, look at your picture, is what? What's the sine of this angle? Square root of 1 minus x squared over 1. Yeah. So we can do all these. They're just little, they're called identities. But I never memorize it. I just have to remember that this is my angle. That's theta. So that means that the sine of theta is equal to x over 1. So if I put it in my triangle, and I can put my theta anywhere I'd like, and put it here. The sine is x over 1. So this is x, and this is 1. Therefore, this is, just like that one, square root of 1 minus x squared. So what's the cosine of that? It's the adjacent over the hypotenuse. So it's the square root of 1 minus x squared. There's 4 of them. Do you want to try the next one on your own? So I'm trying to find the cosine of the angle. Because remember, this is my angle. This is my angle, theta. So I want the secant of that angle. What does this mean? It means the tangent of theta equals x over 1. Then I want to take the secant of that angle. So first I find the angle. Well, I'm not really finding the angle, you're right. I'm finding the sides that go with that angle. So x goes here. This goes here. What's this one? Square root of leg squared plus leg squared. 1 squared plus x squared. Because it's the tangent. So this is the opposite leg over the adjacent leg. I have to put the 1 in there, though, so I can't do it. It's a ratio.
Yeah. Sorry.
That's okay. You got to ask those questions. And then this is Pythagorean's theorem.
So, are we finding the side length again?
We're going to find the secant of that angle, so we're going to find a ratio. Not the angle, it's the ratio of the sides. This helps me get all the sides. The tangent of the angle, I know that this is x, this is 1, that I can find all the side lengths. Is that okay? That's what you want, but then I want to go further. I want the secant of my angle. So I want the secant of this angle right here. What's the secant? It's the hypotenuse over the leg. So it's the square root of 1 plus x squared. So when you had the secant, what was the secant squared of y? It was like that. That's why they got those weird answers. And I said, don't worry about it yet. So what about this one? I always have to look at it. And then I see that little -1, I'm going, oh, that's an angle. That's theta. So the secant of my theta is x over 1. And I could go back and rewrite it as cosine, but why don't I just do the problem instead? It's easier. So where does the x go? Everybody see that? It's on the hypotenuse. And the 1 goes here. And so what's this side? Square root of x squared minus 1. What's this one? Because this is leg squared plus leg squared is the hypotenuse squared. Whereas to get the leg, you have to do hypotenuse squared minus this leg squared. And the other one, and the cosine one, I had to do 1 squared minus x squared. Yeah. I just draw the triangles. And so what's the tangent now of this angle? It's this leg over this leg, right? Square root of x squared minus 1, just to exaggerate, over 1. So I need that to do my next page. And you'll see that problem you were talking about. I don't even remember what the problem was, where you got the secant squared of y. Somebody changed it to x, because you wanted an x there. But it was a y. Huh? Yeah. Okay, we ready to change pages? Okay, here's what we're going to do. We're going to find the derivative of our inverse trig functions. And I was thinking, I could just told you what it is, but it's kind of nice to know why we did implicit differentiation. I'm going to use it also with the logs. Because I don't know the derivative of that, do I? But this is theta, right? This is an angle, correct? So this means, I don't know if I have enough space. Right. And really, there's only the 2. I'll tell you what the cosine is. This means that the sine of my angle is equal to x over 1. Now, I want the derivative of that. Oh, let's call it y. Then I'll get a dy dx, so you'll be happier. Okay. That means the sine of y. I can call it whatever I want, but I would like to do that. And then what I'm going to do is take the derivative of both sides. This is explicitly solved for y right here. This is implicit. Remember, y is embedded inside of another function. It's okay. So why did we do that? We did that so we could do this. I'm going to take the derivative. That's the operator. It's like adding something to both sides. So, and I think you guys got this part of on the quiz. I don't think this was the issue. What's the derivative of the sine function? So that's right. So it's the cosine of y times the derivative of the inside function, y prime, or dy dx. I don't care, whichever you like, y prime. Okay, equals what? 1. And my goal is to solve for y. I want this guy by itself. So what do I have to do to both sides? Divide by cosine of y. Okay, but I don't want a y in my answer now. That's the problem. What's the derivative of x with respect to x? What's the slope of just x? It's x prime. Okay? So y prime is equal to 1 over the cosine of y. But what is y? We know what y is. What's y? That's the inverse sine of x, right? And we just did a bunch of problems that look like that. But I don't memorize those identities, so why don't we draw the picture? This is my theta, so that means the sine of theta is equal to x. So here's theta. The sine of that angle is x. So this is x, right? And this is 1. And this side is square root of 1 minus x squared. So what's y prime? Y prime is equal to 1 over the cosine of this angle. What's the cosine of that angle? Square root of 1 minus x squared over 1. That's the derivative of the inverse sine. We got to get that sheet for you. Well, I'm giving you this tool because in case you're in the middle of the exam and you forget that one, you can figure it out. But you should memorize it. What if I tried to do the chain rule? In fact, we're going to get rid of the secant because I don't care about those. You can look those up in the book. I don't even know what they are. You can figure it out, but anyway. What's the derivative now with a composite function of the inverse sine? Well, the derivative, I'm going to write this out here again, of the inverse sine of x is 1 over the square root of 1 minus x squared. It's the same as what I have there. But what if I do now the derivative and put a composite function? Then where you see x, I'm going to put in f of x. So this will be replaced with that function right there. It'll be okay. So that's equal to 1 over the square root of 1 minus, I'll change colors, that's f of x squared. And then what do you have to do? Chain rule. Multiply by the derivative of the inside function, f prime of x. So first you do the derivative of the outside, which is inverse sine, but that's your input. Took the derivative of the composite function, inverse sine of f of x. It's this question right here. I said, what if it's just inverse sine of x? That's this. What if you put a function in here where you see x, you're going to put in f of x. This is the one you know. Well, I have to know. Should be probably up my wall someplace. There's the inverse cosines up there. Pardon? Yeah, because they're always gonna give you a composite function. They're not gonna give you just inverse sine of x. So, do you guys want to try doing the tangent one yourself? We're not gonna do these. We won't see them on the exam, so we're not gonna do them. How about the tangent, inverse tangent? You want me to do it, or you guys want to try it? Yeah, that's it. That's it. So I would like, if y is equal to inverse tangent of x, I want to find dy dx. So what I would do is rewrite it as the tangent of y is equal to x over 1. Do you remember the derivative of the tangent?
Yes, it is.
I'm going to just to get you to show you how to do those identities. That's right. It's secant squared. So we're going to take the derivative. I like to use the operator because, I know you guys don't necessarily like it, but it tells me what I'm doing. If you read a calc book, it's going to be there. So this is secant squared, but not of x, but of what? What's the inside function of y? Times the derivative of the inside function, y prime, which is equal to 1. What's similar? I got secant squared, because the derivative of tangent is secant squared. It's what it is. You have to memorize these. There are some things you have to memorize, and the theorems. So what's y prime equal to? 1 divided by secant squared of y. That's problem 5. But I don't know what y was. Well, y is equal to inverse tangent of x, right? Okay, so let's draw a triangle. Because y is my angle. I'm going to actually go back to here. The tangent of what angle is x over 1? So what's this going to be? This is x, right? This is 1. Hypotenuse is square root of x squared plus 1. Yeah, this is on the, kind of a, part of it's on the other thing. So what's the secant? The cosine's 1 over square root of x squared plus 1. Secant is, okay, so that's equal to square root of x squared plus 1, but what do I have to do to it? It's what? No, it's squared. The y is gone, because this is the secant of y, which is this hypotenuse over the leg, and so this is 1 over x squared plus 1. I already did. Cosine was 1 over this, secant this over the 1. We did. We did flip it. So if you'd rather do it this way, let's do it this way. This is cosine squared of y, which is, a cosine squared of y, I can't see my triangle, is 1 over that squared. It is flipped. Yep. So this is just 1 over. And usually it's written this way, 1 plus x squared. You don't know why, but it is. You'll see it both ways. You'll see it more often written 1 over 1 plus x squared, and you're going to realize, oh, that's just an inverse tangent. They're the only ones you have to know. Whoops. The derivative, actually I'll give you a third one. I'll just give it to you. Of the inverse sine of x. Anybody remember it now? 1 over the square root of 1 minus x squared. Okay, let's do the derivative of the cosine. Inverse cosine turns out to be a negative 1 over the square root of 1 minus x squared. If you think about it, that should make sense, because inverse cosine and inverse sine, they're just complementary angles. They're related to each other. Tangent's a little bit different. And the derivative of the inverse tangent function is 1 over 1 plus x squared. Then next Tuesday, we'll do 2 to the x, e to the x, in logs. And that will be all our derivatives that we need to know. We're done with how to find them, and then we're going to go do what the derivatives tell us about our function. Because you'll never ever collect data about the function. You will collect data about the rate of change of the function. You might be able to make predictions on that. And there's a lot of different things. And then in January, actually after the exam, we start reversing derivatives and find antiderivatives. The bulk of the course is really done by the end of first semester. Second semester, we just have 1 more quarter of new stuff. It all builds on all the old stuff. Okay, what's the derivative then of this guy? What if I have a composite function? I'll do green because I don't have any green in it. It's 1 over 1 plus the input. What's the input? It's x here. It's not x, it's f of x. So it's f of x that's squared times the derivative of f of x, which is f prime of x. And of course, you'll just have some practice problems. Some will be applying this. Have anything more on my slides, I think? What's this one? Let's do some examples. We're going to skip the particle ones I don't care about. And then the last page is for you just to fill all those in. But I'm going to get you another one too. Okay, so how do we do this? Do I need to write? Let me slide my board here. Because what I'm going to do Maybe we'll do that another day. We'll do the derivative of inverse functions. That's tricky. And let's just put this right up here. The derivative of the inverse sine of x is what? 1 over the square root of 1 minus x squared, right? Which page are we, what's the problem? Yeah, we got all those. And then this one, make sure you put that down there. And then then I have some examples here. We'll skip the particle motion one. So this is 1 over the square root of 1 minus, and this is what I have to put in for my x. So what's it going to be? X squared to the what power? Yeah. Times, and then I have to do the derivative of the inside function, which is? This is the easy part. What's the derivative of x squared? 2x. And we will not simplify or anything. We'll just leave it. Even if you do this wrong, we'll get it right, because that's x to the fourth. Michael. I took this formula here, and this is, if I make this f of x, then this is f of x. So you have to substitute whatever that is. Let's do this one, because it's the same thing. So you have to know the formula. It's 1 over the square root of 1 minus, what's my input now? 3x minus 1, and you're going to square it, but we're not going to square it, okay? Let's leave it like that. Times the derivative of the inside function, times by 3. Yeah, it's a matter of memorizing these and then remembering to apply the chain rule. Now, do you remember what the derivative with respect to x of the inverse tangent is? That's my favorite. 1 over 1 plus x squared. That's not bad. So this is 1 over, I like that better than the ones with the square roots. It's 1, no, because remember it was secant squared. Okay, so it's 1 plus whatever this is, squared. What is that squared? Can I just go ahead and write it? It's just x plus 1. Or is that too fast? Then I get to the chain rule times the derivative of this. So I need the derivative with respect to x of x plus 1 to the what power? 1/2. So it's times, remember how to do that one? 1/2 x plus 1 to the what? Negative 1/2 times the derivative of the inside function, which is? That's good. That's good enough. Pardon? Well, you will. Oh, we could do this. This is just a velocity. Well, it's just another derivative. How do you find the velocity? Oh, no, you shouldn't get confused. How do you find the velocity? It's the derivative of the position. So I have to just take the derivative of the inverse tangent of the square root of t. So it's just another problem like the last one. Make that y and make that x, and you'll have it. So what's x prime of t? Well, it's the derivative of this. I don't have it in front of me, though. There it is. So it's 1 over 1 plus x. What's my input here? Square root of t squared. So it's just 1 plus. Okay, so square root of t squared, which is just 1 plus t, right? Times, chain rule, and then it's t to the 1/2. It's just like what we just did. It's what? 1/2 t to the what? Negative 1. And you can substitute in 16. Do we have any problems with doing that? We might. So I better simplify it so I can do this better. It's 1 over 1 plus t times, and then this is 1 over 2 times the square root of t. If you substitute 16 in here, and 16 in there, t to the negative 1/2. is a square root, but because it's negative, it's in the denominator. Okay, the negative puts it in the denominator. So I just put in 16, so it's 1 over 1 plus 16, which is 17, times 1 over 2 times the square root of 16. So it's 1/17 times 1 over 8. I don't know what 17 times 8 is. But honestly, if this was a free response question, I would leave it like that. You've got full credit. If it's multiple choice, you won't have any choice but to figure out what it is. And I think that's the last one.
So how is that the dx?
It's just the derivative. It's the that v is the dx dt. It's the derivative of x with respect to t. Just find the derivative. Your velocity is your first derivative. What's your acceleration? Second. I don't want to do the second derivative. It doesn't look like fun. Because I have to use the product rule. Ooh, I don't want to do that. I could rewrite it, but I don't want it. Sometimes it's easier to use the quotient rule than the product rule. Now, you guys can fill this out. Don't worry about the cotangent and the secant, so we aren't going to do these. They're probably, you might have a problem in the book. You'll have to figure out how to do that then. And hopefully we took those out. I've just never seen them on the exam. And you tell me if you have. So you should be able to do that. And we need to do it together or give you a chance to do it right now. See if you can do it. Yeah. And what I'll do is hand back your quizzes. Just see if you can fill it